Dear students, today we are going to solve question number 10 of exercise 8.1. The question is ABCD is a parallelogram. In the figure we are given ABCD. It is given to be a parallelogram, and parallelogram, as we know, is a quadrilateral in which the opposite sides are parallel and equal. And AP and CQ, here AP and CQ are perpendiculars from the vertices A and C. AP and CQ are perpendiculars from the vertices A and C on the diagonal BD. Show that the first part is we have to prove that triangle APB is congruent to triangle CQD. We have to show that this triangle APB is congruent to triangle CQD. These two triangles are congruent to each other. Congruency, as you know, implies the two triangles are of the same shape as well as of the same size. And the second part is we have to show that this side AP is equal to CQ. Here, solution. Since we know that AB is parallel to CD and BC is the transversal, as it has already been pointed out that if we are having two parallel lines, if the two lines are parallel to each other, and suppose L is the transversal is the line which intersects these two parallel lines at two distinct points, then as we know the alternate interior angles are equal. Here this angle is equal to angle 1 is equal to angle 2 because the two lines are parallel to each other, so it implies the corresponding angles are equal as well as the alternate interior angles are equal. Here AB is parallel to CD or DC and BD is the transversal. So obviously this angle, angle 1, let it be angle 1, it will be equal to angle 2 because these are alternate angles. Now, when we consider these two triangles, triangle APB and triangle CQD, here angle 1 is obviously equal to angle 2 and angle APB is equal to 90 degree and angle CQD is also equal to 90 degree. So the two angles or the corresponding angles in the two triangles are equal. The side AB is equal to the side CD because the two sides are parallel and equal. Therefore, by angle-angle congruency rule, the two triangles are congruent to each other. Since AB is parallel to CD and BD is the transversal. Therefore, or which implies alternate angles are equal. Therefore, angle 1 is equal to angle 2 because these are alternate interior angles. Now we will consider two triangles in triangle APB and triangle CQD. Angle 1 is equal to angle 2 because these are the alternate interior angles, and angle APB is equal to angle CQD, angle CQD because each angle is equal to 90 degree. Again, this side AB is equal to side CD. Also, AB is equal to CD. Why? Because the opposite sides of parallelogram are parallel and equal. Opposite sides of parallelogram ABCD. Therefore, by angle side criteria of congruency or angle side congruency rule, triangle APB is congruent to triangle CQD. Thus, the first part has been proved. Triangle APB is congruent to triangle CQD. Second part, AP is equal to CQ. Again, we will consider these two triangles, triangle APB and triangle CQD. Obviously, this side AP is equal to CQ. Why? Because these are the corresponding parts of two congruent triangles. When the two triangles are congruent to each other, the corresponding angles are equal as well as the corresponding sides are equal. Second part, it follows from this, AP is equal to CQ because the two triangles are congruent and AP and CQ are the corresponding parts of congruent triangles.